Okay, so the next thing we're going to talk about is, obviously we have graphs that we can use as a picture of stuff that we have on a plane, but we can also write an equation, and that tells us about the relationship between the x and the y. So if I look at this point here, this is 1, 1, and here would be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This point would be 5, 5. If I were to draw a line through those, I would have a specific line. And one of the things that I've always found is that drawing the graph depends on how precise you are. So you have to be careful. I really suggest, if you can, using a straight edge, just because it makes you more honest and it's more reliable. But this is a line, and every single point on this line, and remember, every line is made up of all these little points squished together. Each of these has the same relationship. So just like this was 1 and 1, and this was 5 and 5, I could come up here to 20, 20, and the relationship, the proportion would always be the same. And don't worry, I'll explain a little bit more about that later. I just wanted to plant the seed. So when we first start out with this, what I want you to have the idea of, just like when with the inequalities, we talked about checking for whether or not the information was valid. Does this input that I use make my equation true? So here we're going to ask ourselves with this equation, and notice this equation is a little more involved than ones we've seen before. It has two variables. It has an x and a y. So what we're going to test right now is to decide whether these points would be on the line we're talking about. And to do that, I'm going to use this value and plug it in for x. So I have 4 times -1 plus 5 times 3. And we have to see, does that make 11? So this will be 4 times -1 would be -4 plus 15 equals 11. And indeed, that does make that true. So again, all I'm doing right now is testing points to see whether or not they're true. And we're going to do that on our next exercise, the next U-try. So this is number 2, and they've given you an equation and 3 points. And we have to decide whether or not these are true. Now this equation looks a little bit different than the last one, so just to make it easier on myself for now, I'm going to rewrite it a little bit so that I have my x and my y in alphabetical order. So it'll be 3/4 x plus 5 equals y. Same as that, I just moved the y and the equal sign to the other side. But I wanted you to be able to see this because you have to be really careful that you plug the right value in the right place. So here's my x, and here's x, 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 and y, 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 and there's my y. So if we're going to prove these are true, we have to plug in our values. So -3/4. All right, so the first one I'm using 12 for x, and I'm using -4 for y. So let's see, 3 times 12 is 36, so that would be -36 over 4 plus 5 equals -4. 4 goes into -36, -9 times. So -9 plus 5 does indeed equal -4. So my first one is true. Let's see if my second one is. -3/4 times 0 plus 5 equals 7. So here, negative 3/4 times 0 is just 0. So this is trying to tell me that 5 equals 7. And that's not true. So this is false. And finally, let's use the last one. Negative 3/4 times negative 8 plus 5 equals 11. Negative 3 times negative 8 would be positive 24 over 4 plus 5 equals 11. 4 goes into 24 6 times, and 6 plus 5 is 11. So this last one is true. So here, I didn't use any graph paper. I just used my algebra skills to evaluate the equation using these values. So I just tested my x and y value. So if I were going to draw a line about that, on that line, this point and this point would be on it, but this point would not. Oops, that point would be up there. So he doesn't belong. Those two, though, are on the line. Okay, that's it for our first video. Thanks very much.